of these problems, and then we're going to move on to the next set. Problem number 12 is x squared. Actually, you know what? Nah, I don't want to do number 12. I'm looking at 14 and I'm thinking, yeah, that's the one for me. 14 is 6x squared minus 2x plus 9 is equal to x plus 2. Cool. Here we go. Let's do this one. So on this one, remember this is a quadratic equation problem, and before either way, whether we factor or use the quadratic formula, it doesn't matter. We need to set this equal to 0. So the first thing I need to do is subtract x and subtract 2 from both sides of the equation. So 6x is all, or 6x squared is all by itself. Now I wrote this over here on purpose because this is what students do sometimes. Those are like terms. Okay? Sometimes students will, like in a hurry, minus it from the x squared term. We won't do that though, right? This is actually 1x, so I've got a negative 3x. And then 9 minus 2, those are also like terms, right? So then that gives me positive 7. And then all this stuff canceled out, and I got 0. Okay? So again, for the quadratic formula, I need x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now what they're talking about, yes?
Since it was 6x squared minus 1x, shouldn't the answer be 5x squared?
Well, that's what I was saying. I said, see what I'm saying? I wrote it over here because I was in a hurry. But can I subtract 1x from 6x squared? No. So we got to be careful about that. Yep. We got to be careful about that. Okay? So now what I want to do is I need my a, b's, and c's. So this is my a term. A is equal to 6, right? B is equal to negative 3. Forgot to put my b in there. And then c is equal to 7. Actually, you can't see that. So let's do c is equal to 7. So to finish this thing, you can't see this very well either. Let's b is equal to 3. That's better, I think, kind of. So we've got x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's do the a's first. I've got 6 here and 6 here. Done with that. I've got b's are next, so my b is, it's negative 3, not positive 3. So negative 3, negative 3. Done with that. And then for c, I've got 7. So I just put my lonely little 7 over here. And now let's crank through that. So when you minus a minus, it becomes a plus. So I've got x is equal to positive 3 plus or minus the square root of 9 minus, wow, 4 times 6 times 7. It's 42 times 4, which is 160 plus 8. So negative 168. Am I close? Is that what you, all right, good. I do math. What? And then 2 times 6 is 12. Courtesy mode. So then I've got x is equal to 3 plus or minus, is that minus 159? What is that? Oh no, they're opposites, right? So that would be, what was it? No. No. Positive 9 minus 168. What is it? Do it on the calculator. Is it negative 159? Wait.
Negative 159.
Let me double check something, because that seems kind of bonkers. Okay? We said that 4 times 6, clear. 4 times 6 times 7 is 168. And then if so it's negative 159. Wow, that's weird. All right. So square root -1 square root 159 all over 12. Okay? So now what? Let's look and see. That seems like a crazy answer, doesn't it? Oh, but you know what? That's part of the solution set. Square root of 159. I'm almost done though. What is the square root of -1? Huh? Isn't that it? Let's see. Which one is that? That is C, isn't it? Right? Because the 3 over 12 will reduce to 1 over 4, won't it? Right? Because this, if I divide this by 3, I get 1. If I divide this by 3, I get 4. So it's 1 over 4. In other words, this is the same as 1 over 4 plus or minus the square root of 159 all over 12. And really 159 I think may even be a prime number. Or it might be divisible. Let me see, 6. No, it's divisible by 3, but you can't take the square root of 3. Okay? How could I without a calculator, this is just kind of a side note, how could I without a calculator figure out if there's a perfect square that goes into 159? Do you guys know how to do that?
Oh, yeah. You add all the numbers and see if they're divisible by 2, I think.
Yeah, this is divisible by 3 because 1 plus 5 is 6 and 6 is divisible by 3 and so is 9. I think it's divisible by 3. So, but what I was going to say is that you could do a prime factorization is another way to do that. And so if you do a prime factorization, is 159 divisible by 3? Let's see. (159) divisible by 3, 53 times. Now, here's the thing. I'm pretty sure 53 is a prime number. So that's it. That's the prime factorization. And so since the prime factors, there isn't a power of 2, there's nothing squared, I can't take the square root of that. There is no perfect square, so that's it. Okay?